Here's a look at the items you're going to need to complete the bullet. First off, with regard to the servo, I'm using a TGY 9018. I mean, for $6 you can't go wrong with it. It will last unless you abuse it. Then you just simply replace the servo. And what I've done is I've cut off the mounting ear on one side there, as you can see, and this lets you mount it to the frame. And then I replace the top on a new servo with this top if this servo here gets damaged. So after about the third servo, you don't have to keep cutting the ears off your servos. You can just replace the top. Motors are 1200 kV, and I also use a regular prop adapter and not the prop adapter that happens to come with those. Props, you need a set of props. You can have, that's actually a set of red props. One is reversed, and then the black matches the one that's reversed. Double-sided tape, that mounts the board as well as mounting the servo. Receiver, I'm using an AR6200, which is probably overkill, but I prefer to use full range receivers, so that's what I use. The wires, in this case with these particular speed controllers, to get the right length, I need 4-inch motor leads. So you need bullets for the motors. And the wire to go in from the plug is 1 3/4 inch and 2 3/4 inch. I have some double-sided tape there to mount the battery. Now the kit does come with a strap, but you'll need a set of Velcro, mating Velcro, to mount battery. Also zip ties. Your kit will come with enough zip ties to build the kit, but you will need extra zip ties for sure. Heat shrink tubing. I use a 40C 2200 milliamp 3-cell battery. Here's a look at what's included in the bullet kit. You get the G10 lower frame. The Dean's connector is pressed into that CNC cut mount, and the Velcro strap, the screws, spacers, nuts, the servo linkage, zip ties, white ones secure wires and the motors in place. The black ones are to secure the servo. That'll look at the upper plate, landing gear, wood parts. I have all the parts available. I'm going to do a quick build video here. This kit goes together really quick, so not a lot of detail, not a lot of things you can mess up. One thing to note is there's 2 different size screws. The 2 longer screws are the screws near the center of the frame, and those will actually be going through the frame as well as the landing gear. So that's what the 2 longer screws are for. All the other screws are the same size. So now let's get on with the building. Here's a look at the layout for the bolts, the spacers, and the wood parts. And there's a couple of unique things about this frame. But first, we're going to take a look at the spacers, and you can see that the 2 upper bolts do not get spacers, and the bolts that are around the wood at the rear do not get spacers. Also, depending on which side you want the plug to come out of, the Dean's plug, this is set up here for it to come out the top, because we're looking at the inside of the top. In other words, this is the bottom frame, or the bottom panel, bottom plate, and it would go on this configuration here where the oval is on this side and the 2 holes are on the side where the plug is. depending on which way you orient the plates for the top and bottom, the power connector can either exit the bottom of the model or the top of the model. And there is even a provision for the side, for it to exit out the side of, and it's just a simple adapter that you can make. Now for the bullet, I have to have 2 speed controllers going in one direction and 1 speed controller headed to the rear. I also have this power block headed to the rear, so the wires will be extending forward. So what I want to do is tie all of these together, and I'm simply going to add a piece of shrink wrap. We'll work with the positives first, and then I'm going to add the power lead, or the accessory lead. So I'm going to slide that up in here. So now I have all 3 of these wires coming up front here, coming together. And now I need to secure these where I can solder them together. So you can do that a couple of ways. One way to do it is just to take a small piece of shrink wrap and put on here, and get them where they're all lined up, and then put some heat to the shrink wrap. And that's going to hold all those together. Then we do the same thing with the other 2 wires. So again, I'm going to take a small piece of shrink wrap and put it on these 2 leads. And I'm going to shrink this down, and that's going to hold those 2 together. The good thing about the shrink wrap, the hotter the wire gets, the tighter the shrink wrap is going to pull it on. So I'm going to be moving this wire out of the way right now so that I don't have to deal with it. And I'm going to weight my plug. Now I'm going to take the positives of all of the wires and put them, I'm going to stick them together so they're all forced as one. And if we look close there, you can see, maybe you can see how that's coming together as one unit. So now let's solder that up. And I'm going to tin my soldering tip here and apply some solder, and I'm just going to let all that solder flow together. So the idea is to apply the heat and let the solder flow, and it will flow, and all the wires and the connectors will come together. And that looks pretty good, actually. So I'll clean the tip, and then we'll let that cool for a moment, and then we can investigate and see that we in fact have a good contact between all the wires with the solder. So now I'm just going to slide this, make sure this is cool. If it's cool enough to touch, it's cool enough to apply the shrink tubing. So I'm just going to slide this over like that. Apply the heat. And now I have the positive leads all together, and they are secure, and I'm ready to do the ground wires. First thing I need to do is go ahead and slide on my piece of shrink wrap that's going to cover up the wires when I'm done, and then I'm going to go ahead and plug these all together. So basically they're going to hold themselves together, much like you see there. So now I'm going to solder that, and the trick to soldering can be very difficult if you're not going about it the right way, and there's probably thousands of ways you can do it, but this is how I do it, and I don't have any problems. So I first clean my tip, and then I add some solder to the tip, and then I apply the heat to the wire that I'm going to solder, and I'm using the solder that I've added to the tip to help transfer the heat to whatever I'm soldering, in this case the wire. And so what I'm looking for is I'm looking for the solder to start flowing, because if the solder is flowing, that means it's gotten hot enough. And so I'm actually putting enough solder on here so that the solder actually comes out the bottom. And because it comes out the bottom, I know that the solder flowed through the wires. So with that said, I've let it cool a little bit, and you can see that I actually have a nice solder joint there, and I do not have a lot of excess solder. So now I let this cool to the point where I can touch it, and if it's cool enough to touch, then that means it's cool enough to go ahead and slide the shrink wrap over it. And now I'm going to draw this down by just applying heat. And now you can see that I have both the positive and the negative wires soldered, and my wiring harness has been completed. And you can see here I have the accessory wire that I'm going to be using. And again, if you're going to be pulling a lot of current, then you probably want to use a larger wire for your accessory. I have the 2 speed controllers. I have the accessory wire, I have my plug, and I have the other speed controller. Also, I've gone ahead and added the links of wire to the ends of the speed controllers for the motor side. So this wiring harness, speed controllers, and plug are ready to be mounted in the frame. From the source plug to the tips of the bullets is 12 inches on the rear speed controller, and from the center of the source plug up to the bullets on the other end of the 2 forward speed controllers is 15 inches. You can see here that I've also soldered in an extra wire going to the source plug, and this will send voltage to the board so that the board can monitor the battery voltage. You can also add a second plug or a second set of wires if you wish to use auxiliary power. For an example, if you want to make it a night flyer and you need power, it's best to go ahead and add that provision now rather than do it later. So this is the wiring harness, and it is ready to install in the bullet. Here I've installed 2 spacers and bolts up at the front, as well as 2 spacers and bolts at the rear. Here the frame is upside down, and I've placed the source plug in its position, and I've also added 2 screws and taken the speed controllers and laid them in, and actually rotated the 2 front speed controllers, twisting the wires so that take up the slack. And now I'm ready to go ahead and lay the bottom plate onto the top plate and put the bolts in it. At this point I've flipped over the frame. We're looking at the top side now, and I've ran the power wire from the battery source plug. This will let the controller board monitor the battery voltage. I've also ran the 3 ESC leads, and I've also numbered them so that this I know is motor 1, which would be this motor, and this one is motor 3, which is the rear, and motor 2 is the one up on the right. And also I've put the Velcro, which is included with the bullet kit, and ran it in so that it is oriented the proper way, which is like this. Here I've added all the spacers to the frame, so I have 5 bolts remaining. One of them is a long bolt, and then I have 2 holes up in the front. These 2 holes are going to get zip ties and not bolts at all. Also, you might notice that there's 2 small holes in either side, and this is These holes are for the speaker. If you're going to add a speaker, you actually put the speaker in the hole and then solder the wires on top, so your speaker will mount basically a surface mount. You might also note that I've tidied up the wires so I don't have a lot of ESC wire sticking out. And this, of course, is the wire for the battery monitor voltage, and it's pushed back in there so you don't have a lot of excess wire hanging out. One other thing on the ESCs, I've actually taken the wire and ran it through the oval hole and then out, and the same thing on the other side. And this will actually be getting a zip tie around this area and around this area. We'll start at the rear. You can see that I've added the wood parts and zip tied the wires. Now notice that the rear wires actually turn and come underneath the bottom, and also I've added a zip tie here. And one other thing to note on this rear speed controller is this wire is on the outside of that spacer. Also on the linkage, I did slide the linkage all the way up into the block, and you want to work this so that it's fairly free. You don't want it to be so loose that it falls down, but it needs to be free so that you're not overworking your servo, and over time that will even loosen up more. So we don't want to start with it super loose. The other thing, the wires, I've zip tied those in place. This would be the last place that you would put a zip tie. In other words, no zip ties on your motor leads coming out here, and no zip ties on your bullets. You want those to be free so that they are able to break away. Also on the bottom here, you can see that I did add the zip tie here and over on this side, and I've also mounted the landing gear. So now I'm just going to tighten everything up, and then the model will be built. Then it's just a matter of adding the controller board, adding the receiver, adding the motors, and the motors up front will be held on with zip ties. The motor in the rear will be held on with screws. Here I've started preparing the frame for the control board and the receiver. The receiver is actually going to sit right back on this pad right here, and it will actually be mounted just about like that. And then the board, the control board, is actually going to mount on the double-sided tape here. So I'm going to peel that off and set the board right on top of that. Now the control board's been set down on top of the double-sided tape, and I've plugged in the battery monitoring plug into the board, and now I'm going to go ahead and hook the motor plugs into the board, which are going to be motor 1, which will be the left motor. The second one there will be the right motor. The third one will be the rear motor, number 3 motor. And I have the 3 motors hooked up: motor 1, motor 2, motor 3, and this it is a 6-inch extension, and it's run back along the side here, along the side of the wood, and it's going to stop right here, and the rear servo is actually going to plug into that. Here I've mounted the rear servo, and the way I've done that is took a piece of double-sided tape, put on the edge of the servo, and then sent it through the linkage after I've mounted the linkage to the servo horn and placed the horn on the servo and tightened it up. Once you do that, then you can slide the linkage through the connector and then place the servo down so that there's no friction on it whenever you rotate the block, and that way you get the servo in the right place. And then to mount the motor, you actually want to favor the front, so we're going to go from the front edge here back about 1/8 of an inch, and then you're going to center it left to right, and that's going to give you a little over 1/4 of an inch in the back. Now this servo should actually be sitting about 5/16 back from the edge of this piece of wood here, or this joint between these two pieces of wood, because you need a little clearance. You can mark the holes and then pre-drill them. I just use the screws that come with the servo to mount the servo, so that screw is sufficient to mount the servo. We're going to use 4 of those. And then the other thing is, you want to make note of how you orient the mount if you're using this type of mount. you want to just make it so that the screws are to the left and right, because if you mount it this way, you can get to the front screw, but it's really difficult to get to that back screw. Also, when you mount the motor, make sure you use Loctite, and don't really crank those down, but you do want them snug, and you do want them tight enough they're not going to come loose. And that's one of the things you should check often, is make sure your screws are still tight, because again, if you crank it down too much, you're going to damage the bearings. One tip on this connector, I actually solder this, and that way I never have to worry about it. Now obviously if I break the arm, then I have to redo it, but I don't ever have to worry about this coming off. So and that's kind of one of my trademarks. Anytime I can solder a connector or a wheel collar, I generally do. Now I have the wood block marked, and I'm going to drill it. I'm also going to drill out about 1/4 of an inch hole. It won't be very deep, but it will allow clearance for the motor, because if we take a look at the motor, if you just set the motor on the block, you can notice the wobble in the motor here. And the reason for the wobble is because the shaft is actually sticking past the end of the mount. So I'm going to drill a 1/4 inch hole about 1/8 of an inch deep. Should allow room for this shaft without bottoming out. So that's one thing you want to pay attention to. Now some might say, well, put some double-sided tape on there, but you're going to be crushing that, so double-sided tape's not going to be enough. Also, whenever you put on your arms, you might want to pay attention to that too, to make sure that you do not wind up with the shaft rubbing on the wood. One of the things I do when I put the double-sided tape on to mount the front arms is I will put the tape across and then come back with an X-Acto knife and cut the center out of the double-sided tape. So this would be ready to mount on the arm. And again, pay attention to which way you mount the plate, because it will make a difference whenever you go to set your set screws, tighten them up. Because again, you can get to it from the sides, but if you mount it this way, you can get to it okay from this end, but on this side you have to deal with the wood. So I just make sure to mount the plates this way, and also you want the plate flush with the edge here. Zip tie around that mount and it is complete. So if your screws are going this way, run your tape, your double-sided tape, this way, like I've done here. Now here you can see I pre-drilled the holes, and I drilled out the center with a 1/4 inch bit, just deep enough to make clearance for the shaft. Now here the rear motor has been mounted, and the only thing left to do now is to cut the shaft of the motor down, and I will be doing that before I put the props on. But you can see the motor is mounted, the wires run underneath and tie into the plugs underneath, and you want to make sure those bullets are tight. If you have a loose bullet, that could be a problem, so you want to do what you need to do to tighten it up or replace it. One other thing you want to check is the clearance on your motor. You want to make sure that it does not hit on your linkage. So again, you want to favor to the front, center it here, and the servo needs to be set back about 5/16 of an inch or so. Just whenever you install the linkage, you want to put your linkage all together and then mount your servo so that you're not pressing or binding on the linkage. Here's a look at the motor on the left side, which would be motor number 1. You can see that I have the double-sided tape underneath the mount, and then the zip ties are holding the mount in place. And now I just need a little Loctite. And the motor, I set my wires so that they are straight down the shaft, and then the wiring harness is done in such a way that the plugs will plug up right there. Depending on what the rotation of the motor needs to be dictates which wires go where. And again, double-sided tape, and then zip tie the mount use Loctite on the set screws and do not over tighten them to the point where you're crushing the bearing. And you also, when you pre-flight, you want to check those to make sure your motors are still tight. Loctite's been used and the motors have been mounted and they are free to spin. The wires, they'll just plug in here, no zip ties along here. The last zip tie would be here. Leave those free. On the wiring harness, if you take a look here, you can see that I'm only using single pins on some of the channels, because whenever you buy the board, if you get the wiring harness, this is what you're going to get. You're going to get some of these, which they're broken individual. So what you do is you hook the ground and the positive on one, or in this case I could use two, and then the other channels you only using the signal. It's really important that you hook this up properly, and if you spend a little time and double check your work before you ever put power, actually you can triple check it before you put power to the board. If you've made a mistake, surely within 3 checks you should be able to catch it. Okay, I have the bullet all wired up, and a couple of things before I go any further. I should explain something, and that is, if you buy the wiring harness or the hookup wire for this board, whenever you get it, you're going to wind up with some wires that look like this, and you're going to wind up with one that's going to have a Futaba end on both ends. You just simply cut the tab. If you need to use a Spectrum or JR receiver, you can just cut the ear off of it and it's fine. But here's the thing with these hookup wires, and you're only going to get 3 or 4, I think. At any rate, that's enough to wire up the receiver, and here's how you do it. You're only going to use 2 of these sets to hook the positive, the negative, and the signal wire to the receiver. And I use 2 of them, and by using 2, I pick up the power off of 2 areas of the board, and I send it to 2 areas on the receiver board. So you use one of these. In my case, I use one for the throttle, and I use one for the auxiliary or the gear channel. On the other one, I use each one of these pins for a signal wire for the aileron, the elevator, and the rudder. So this would give me aileron, elevator, and rudder from the control board to the receiver. In other words, you don't need a ground and a positive from every channel. So that's why you only get the wires the way you get them. And if you go about it the right way, you shouldn't have any trouble. Just double check and triple check your work before you power the board. Another thing, whenever a model comes in my shop, I don't care what it is, I don't care who it is, before we hook a battery to the model, the props must come off. So we're going to take the props off and set those aside, and I'm going to take you through the programming. The first thing you're going to have to do is, and it's always good to do this, is to reset the board to the factory settings. Maybe you've bought a used board, or maybe you bought a demo board, or maybe somebody said it was a new board but maybe it wasn't. It doesn't matter. If you will reset the board to the factory settings, then you start with the known settings, which are the factory settings, not what somebody's programmed in or put in. So the first thing we're going to do is, of course, bind your receiver, and I've already done that here. Also, a little tip for you, I throw a bind plug on the back on this servo, so in the pictures, you probably noticed the bind plug, and that's just a quick handy dandy if I'm going to let somebody fly the model and they want to use their radio. They can just grab this bind plug, bind it, and put it back. Also, I can show you, you probably wonder what the heck is all of that letters up there. Okay, let me explain these letters up here and what they mean. This is the receiver that's going with this model, and the BTAERGA stands for bind, throttle, aileron, elevator, rudder, gear, auxiliary. And if we look at this receiver, it has those same corresponding pins. The first set over here is the bind, and the difference in this receiver, I actually had to put the pins on this receiver, which is not a problem. I've even done a video on putting pins on the board, so if you're interested in doing that and want to see a simple way to do it, check out that video. But on this one, to designate the bind from any of the other channels, I leave out the center pin, because on this particular receiver, that is basically a bind pin location and not a bind or power location. So I can leave out the center pin and it doesn't affect anything. So therefore, a quick look at this receiver and you know that the bind pin is on this side. So if we follow my letters up here, the next one is throttle. And notice it uses 3 wires, so I'm sending power and a ground from the board to the receiver through my throttle. And then the next set, you notice that I'm only using the signal. I have brown, red, and orange. And that brown, red, and orange, brown is of course the aileron, red is the elevator, and the orange is the rudder. So AER is brown, red, and orange, and those correspond over here. Now also on that particular plug, I've also painted it blue. The wires have a blue mark on them, which maybe you can see right there. Notice these do not have marks, but this one here is clearly marked in blue. That just designates that that is this pin right here, or this set of plugs, and that way I can keep them separate. And then finally, the gear channel, it's going to use 3 wires. Go back over here and they plug in on the control board. Now you got to keep in mind too that on your control board, all the inner pins are the signal. So the inner pins over here are signal, and the inner pins here are signal. And just to clarify, the rear servo, it gets plugged in over here on the motor side, and it is the 4th pin. So you want to double check and triple check your work to make sure you have all your plugs plugged in properly. And once you do, and you've double checked and triple checked that, then we're ready to apply power. And the first thing you're going to do whenever we apply power is we're going to need to reset the board. I recommend that you reset the board to the factory settings if that's an option on your board. So what I'm going to do is turn on my transmitter, and I'm bringing you in here close so you can see all of this. And now we're going to plug up the board. Okay, your first step is going to be to scroll all the way down to the last option on the board, and that's going to be factory reset. And you want to press enter and say yes, and then you should get an error message, and that's fine, because now we're going to start again. We're going to start with our programming. So the first thing we're going to do is load motor layout, and we're going to select the servo M4, and we're going to say yes because we're sure. And then you can look here, you see the motor directions. Then we're going to go to mixer editor, and here we want to switch over to channel 4, and there we're going to switch down to rudder, and then we're going to change that to -100. And once we change that to -100, we're going to save that. So we'll back out, and now we're going to go to ACC calibration, and we want to press continue. We want to make sure the model's on a level surface and press continue, and then it's going to go through its little deal and it will count down, and then you'll press continue because then it will be done. We'll press continue once more, and now we're done with the calibration. Now we're going to go to miscellaneous settings 3 and change the servo from no to yes, and we're going to save that. And now we're back out into the main screen. Now we're going to check the auto level. You can see it's off and then on, and then you want to make sure your switch is correct, in the correct position for on and off. Once you have that, you are done. I use switch A on the back of my DX18 for the simple fact that whenever I'm flying, if I need auto level very quickly, all I have to do is pull up on the switch. And also this would be auto level on, and that would be auto level off. On, off. Okay, now that the bullet has been set up, and whenever we energize it, we want to make sure that we test to make sure. So this is in the up position, so that should say auto level on the board, and maybe we can tell that that says on, and that would be off. And now to arm the motors, we're going to hold the stick, and notice the red light comes on and it says it's armed. And now we can advance the power a little bit, and all the motors are starting. One last procedure is to bring all the speed controllers together. So we want to sync them, and we do that by a sequence of events, and I'm going to show you that now and try to get this in the camera. But what we're going to do is we're going to power up the model, and then we're going to hit the 2 outer buttons with the throttle stick all the way up. To calibrate the ESCs, you have to do a series of events here, and they have to be done rather quickly. And you want to make sure you do this without the props on. What I'm going to be doing is turning on my transmitter. Power to 100%. I'm going to plug up the battery and then press the outer 2 programming buttons and hold them. And now I got pass through, and now we're done. So I can let go of them, and we're completed with the process of calibrating all the ESCs. So now when I advance the power, then the power does come up on all the motors at the same time. So to disarm, we move the stick to the left, and to arm, we hold the stick to the right. Okay, the last couple of steps to complete the bullet is add the Velcro for the battery, and I just put a mating piece of Velcro onto the top of the frame. Also, you want to put your props on. These are counter-rotating props. This would be the left motor, and it's going to turn clockwise. That's number 1 motor. Number 3 motor, which is the one at the rear, it's also going to turn in the same direction, which is clockwise. And the motor on the upper right, which is motor number 2, it's going to be turning counterclockwise. So that is pretty much the completion of the build. One other tip I can give you on the servo: you want to angle it with the arm straight across on the servo arm. You want your motor to be tilted slightly. That's about 5 degrees. That may be a little bit much, but we'll know as soon as I lift off the ground. The model should lift right up. There's a couple of things that you want to get a hold of just to have on hand, and that is some zip ties. These are 18 pound and these are 40 pound. I'm using the 40 pound to hold the servo on, and the 18 pound of course holds all the wires and is put up in the front to help hold the wood in place. But these are allowed to pop and give some cushion to a hard landing. So be prepared to replace those, and also the ones on the motor. Those are also 18-pound. So that's it for the build of the Bullet. Hope you've enjoyed this video, and I hope maybe I've given you enough information that you can enjoy your Bullet or move on and use the techniques in some of your own projects. Thanks for your time, and enjoy the hobby.